Okay, here we go. Do me a favor, put the yearbooks back away, put the phones back away. Let's come back together. All right, so like I said, 425 talking about expected value. And basically expected value will tell you whether or not a game is fair based on what you expect to happen, the expected outcome of the game. And so we were just talking about, Nick had said that if we're talking about 10 spins, 5 out of those 10 you can expect to have $0, and the other 5 you expect to win $4, meaning a total of $20 between the 10 spins. Okay? What if you played the game 30 times? How much would you expect to win? What is it? Yeah. Half the time you would expect, 15 spins you'd win nothing. The other 15 you'd win $4 for a total of $60. Or what if you played this game 100 times? You would expect to win, half of the time. 50 times you would win $4. 200 times. So when we get to the idea of expected value, do me a favor again today, there's a lot of those little conversations going on. Let's focus, okay? Tomorrow's going to be more of a chance to work your way through it. If you miss all the little stuff today, you're not going to have any idea what's going on tomorrow. Let's shut down the little conversations a little bit, okay? So now when we get to expected value is kind of what do you expect to happen on average? If you were going to win, how much would you win or lose per spin? Okay, this is how much over 10, 30, 100. How do I calculate the expected value per spin? What do you think? What do we do? I'm going to show you 2 different ways, but if it's $20 for 10 games, how much do you expect per spin?
So what the equation be 4 times n divided by 2.
Okay, yeah, that's the right idea. Which comes out to $2 per spin. Okay, because if you notice, $20 for 10 games, $60 for 30 games, $200 for 100. In general, what's happening is you're winning $2 per spin. Okay? Every time you spin it, on average, you're winning $2. That is what's called the expected value. Okay? Expected value is what's happening on average, or what can you expect to happen. So 2 ways you can look at that. I'm going to kind of show you 2 options, and then we'll do one more together, and then I'm going to have you kind of practice it on your own a little bit. So one option, and I think this goes to like what Nick was talking about before, the probability of earning or winning $0. You have, I'm just going to do this at the bottom, probability of 1/2 times how much money you're going to win. Okay? Probability times the outcome. Plus probability of the other half of the circle, 1/2. Multiply that times that outcome. And total, this is everything that could happen in this game. 1 out of 2 probability of landing on a 0, plus a 1 out of 2 probability of landing on a 4. And now if you do the math, there's the $2 right there. The average is $2 per spin. That's one way. Probability times outcome. Second option is basically what we just did up in part A. You could go through and figure out, just on average, what would we have? We did that in part A multiple times. So if we just looked at this, if 1 out of every 2 spins, you're going to get a 0, I could say, all right, well, 1 time I'm going to get $0, plus 1 time I'm going to end up winning $4. That gives me a total of $4, but that's per how many spins? 2, which means I can basically just take the average. Divide that, but that's per 2 spins, meaning on average, this is $2 per spin. So you can figure out the total and then divide it by however many spins you're dealing with. Same thing we did in part A. Either one of those will give you the expected value. A quick question, by the way. Is this a fair game to both sides? So like, let's say this was a game that I said, here's a spinner, and I win versus you win, and this is the game. Is this fair to both you and me? Why not? You were the lone person that said no. That's why I was going with it. What's wrong here?
One said $4 and one said 0.
It's got something to do with it. Now, let me re-explain. Let me re-explain. You're not understanding me right. I don't mean that I get 0 versus 4. I'm not talking about the two halves of the spinner. I'm talking about I win versus you win. Period. Okay? The idea here is you're winning $2 per spin. What's the chance that I win? And what I mean by that is, like, if I'm just the one who's saying, here's the game. You go ahead and play. Do I ever have a chance of getting any money back? No, you're winning every time. On average, $2 a spin. Which means that's the idea of, so in this game, for example, I would have to go through and say, all right, well, if you're going to win $2 per game, I would then have to charge how much? If I want to make money, I'd have to charge more than $2 on average. If I would say, all right, if you want to play the game and we're going to break even, I would say, all right, you get $2 a spin. Now it becomes an even game where I'm charging you $2 and on average you're winning $2. Okay? And so now it becomes even again. Let's take a look at the next problem. Same idea, just a little bit different spinner. And again, we're going to calculate the expected value of this spinner, meaning on average, how much would you win? And then we'll go from there. So once again, we'll do this two ways. Notice in part A it says if you win the amount that comes up on each spin, how much would you expect to win after 4 spins? What's the answer to that? How much total would you win after 4 spins? You can do this math. You can do the math in your head. Nope.
104.
104. How'd you get 104?
Well, let me just say, like you get $0 2 times, and you get $4 one time, and you get $100 one time. So that adds up to 4.
So think of the probabilities. Look at the spinner first. Probability of landing in this area. 1/4. 1/4 of the circle. So 1 out of every 4 spins you would expect to land there. Same idea here. 1 out of every 4 spins. Down at the bottom then, since I'm dealing with fourths, I'm going to try to stay in fourths. So even though this is a half, I'm going to write this as 2/4. So 1 spin, you would expect to win $4. Another spin, you would expect to win 100. And the other 2, you would expect to win nothing. For a total of $104. Now, using that same concept, what would the expected value be then per spin if you win $104 per 4 spins? And this, I think, was about what you were doing before. How much would you win on average then per spin? You're in the ballpark. That's what I was saying. You're close. Yeah. Somebody said it. 26. How'd you get 26, Alex? Yeah, if this is $104 over 4 spins, you're just taking the average. Just divide it. 104 divided by 4, the expected value for this game is $26. Okay. On average, you win $26 per spin. On average. So now if you take a look, so that's one method where you can take, and all this came from was the $104 per 4 spins. That's what gave me that 26. You're basically finding the average. But I want you to notice down below, they also did it a different way. This is option number 2. Only difference is where you take the probability times the outcome. Probability of getting a 0 is 1/2 of the circle. Probability of winning $4 is 1/4. Probability of 100 is 1/4. And therefore, you add all that up, you will also get $26. This gives you the exact same amount. Which means, if we talk about fair versus not fair, If let's say I'm running this game and I say, all right, I wanna at least break even. How much should I charge for the game per spin? $26. I need to charge $26. That will make it fair. If I want to make money, I would charge anything more than $26, and theoretically, I should come out ahead then if I'm the one charging you that amount of money. Because on average, you're going to win $26 per spin. Okay? How are we doing? Is stuff making some sense? Get the idea? Here's what I want you to do. Go to the next one. Same idea, they're just continuing to change some spinners here. So if you think of this in terms of money, notice. This time, if you land on a positive number, you win that amount of money. If you land on a negative number, you lose that amount of money. Okay? First question, let's answer part A just real quickly together. Before actually doing any expected value or anything, just by looking at the spinner, what do you think? Predict. Is the average person going to win or lose money? Say win, why do you say win?
Because half of it is positive, half of it is negative.
Okay, yeah, so if you look half and half, Connor says we've got winning $8 versus losing $7, so there's better chance there. Anybody think something else? Or do you agree that probably winning? Okay, let's take a look. Now what I want you to do, I'm gonna have you calculate the expected value. And I don't care which method you use in terms of calculating the total and then finding the average, or if you want to go through and just find it as you go. Okay, probability times outcome. But I want you to calculate the expected value. The one thing that I'll help you with, at least at the beginning here, anybody tell me why they're telling you that this is 45 degrees? Okay, that's part of it. Yeah, we're trying to figure out, well, therefore, what part of this is out of the entire circle. So if you take 45 out of 360, it turns out that this part of the circle is 1/8. That section of the circle is 1/8 of the circle. Okay? 45 out of 360. All right, what I want you to do, calculate the expected value of this spinner. See what you get. On average, will you win or lose money every spin?
Oh, that would be. I think they will. They'll win because it's 3. That would be 3. It's 4.
If you're stuck, please let me know. I did put the probabilities at least up on the screen. So you have the probability of each part. They come up as syntax. Put them times and you figure that'll fix it. Does that look correct? For the expected value? Yeah. No, something's wrong. Right here is what's wrong. Is it 4 out of 8 on that average circle? 6 out of 6.
Is that one right?
Yep, that's better. All right, let's take a look. See what you came up with. Again, I'm going to do this two different ways. Not because you have to do it two different ways, but because some people might be doing it one way, some people might do it the other. I'm going to start with the probability portion. If you just take the probability and multiply it by the possible outcome, okay? For example, the -5. If I'm going to lose $5, 3/8 probability of that happening. So down here, I'm just going to do the work down in this point. So if I take 3/8 times -5 plus 1/8 probability of losing $2. So 1/8 times -$2 plus, notice by the way, I put this as 2/8 rather than 1/4. If you're doing it this way, you don't necessarily, you could leave it as 1/4, that's fine. When I do it the other method, it'll make more sense leaving it as in terms of eighths. And I'll talk about that when I get there. But, so 2/8 probability of winning $2. And finally, 2/8 probability of winning, what was it, $6. Quick heads up, when you plug this in, if this is the way that you do this, when you plug this into your iPad calculator, you need to put multiplication symbols between the fractions and the parentheses. Otherwise, it's going to come up and tell you syntax error. I don't know why it shouldn't, but it does. So make sure you put 3/8 times -5. 1/8 times -2. If you leave the multiplication symbols out, for whatever reason, it's not reading it as multiplication. So just a quick heads up. What you should get, if you actually do the math on that, you should end up with a -0.125. And remember, this is money that we're talking about is what's going on here. Which means if I round to the nearest cent, that means that we have a -13 cents. Now, let me revisit for a second. Didn't we say at the beginning, Connor had said to me, there's a +8 here and only a -7 there. Why are we coming out with an expected value of a negative? On average, we're losing 13 cents per spin. Why is that negative and not positive? Based on the spinner again, Lynn?
There's a larger probability of getting -5.
Because even though when you look at the circle as two halves, yeah, there's more positive than negative per half of the circle. But the largest probability of anything happening is losing $5. And because that probability is higher that you're going to land on that, that's why that then affects the expected value. Okay? So you end up with, like I said, on average, losing approximately 13 cents per game. Now, if you did it the other way, okay, here's the other option. If you look at this in terms of a total of 8 spins, and what would happen every 8 spins, well, 2 of those 8 spins, you're going to win $6. Okay, on average. 2 of those spins. So, that's a +$12. Plus, 2 of those spins, you're going to win $4. That's another $4 of winning. Plus, 1 of those spins you can expect to lose $2. So we'll have -$2. Plus, 3 of those spins you can expect to lose $5. Mean for a total of -15. If I put that all together, we have 16 and then we have -17. So you end up losing $1, but that's per how many spins? Over the course of 8 spins, you will lose $1 per 8 spins. So if we divide that by 8, -1/8 just happens to be 0.125 as a decimal. You get the exact same thing. Okay? So, like I said, it does not bother me either way, whichever one makes more sense to you. To find expected value, that's perfectly fine. By the way, is this game fair? It's close, right? We're only about losing 13 cents, but the person playing the game is at a disadvantage because they're on average, they should lose 13 cents per game. Okay? There is one more problem, but I don't think we're going to quite get to it. So we'll kind of finish that up. What I want you to do, actually, here's what I want you to do with the last, 4 minutes. do part A of the last problem, and then we'll discuss the rest tomorrow. Set up an area model, read the problem, set up an area model, and calculate the probability of winning. So make sure you read the directions because this game is a little different than the other ones. And then set up your area model or tree diagram, whichever one you prefer. Yeah, $100 is 1/8. You're spinning twice. So if you're making an area model, the first spin is on one side, the second spin will be on the other side. And that's the probability of each thing. And that's the thing.
I don't know, I just wait, so
All right, start working. 4-2-4, practice to learn, get that in. 4-2-5, try to start working on the first half of that at least. Otherwise, have a good day.